Hi everyone, in this video we're going to look at the concepts of concentration. So let's get to it. So over here we got concentration, and concentration there's actually two units. So it's actually mole per dm cube, which mole by now you should know it is actually the number of particles, right? And gram per dm cube. So gram per dm cube is the amount of mass you actually dissolve in a solution. So concentration is actually the amount of dissolved solute, right, in a unit volume of a solution. And one thing that we need to remember is the conversion of 1 dm cube to 100 cm cube. Also do remember that sometimes we see that 1 dm cube is actually equals to 1 liter. So that's sometimes what you see in other materials. So what does concentration mean? Concentration, if let's say for example I have 2 moles per dm cube, that means in 1 dm cube of solution or 1 liter of solution, I have 2 moles of substances, right? That's what it means. So the formula is actually just if the concentration is in grams per dm cube, the formula would just be the mass in grams divided by the volume, right, in dm cube. Okay, and if we want to find out the concentration in mole per dm cube, it will just be the number of moles in, again, mole divided by the volume in dm cube, right? However, we also have another way that we can calculate this, knowing that gram divided by mole, mr, molar mass, is equals to mole. You can also do this. You can do concentration in gram per dm cube, right, divided by molar mass, and we will also get the concentration in mole per dm cube, right? So I think what's important first is to have the fundamental understanding of what concentration is. So let's take a look at this simulation. So I'm going to add some sodium chloride. Currently, if you can see over here, I have 500 liters, 500 ml, half a liter. I'm going to add sodium chloride. When I add sodium chloride, you can see that the concentration of the sodium chloride has increased. Now it's about 1.29 mole per liter or mole per dm cube. Now let us think. If let's say for example this is my soup, I added salt to the soup. What happened to the concentration if I'm going to add water, just water? So you should know that by adding water, the concentration should decrease. So let's watch. I'm going to increase water, add water to about 1 liter, and you can see, oh, my concentration has decreased, right? The concentration has decreased. Now, what happens if I scoop up some of the soup? Will the soup have the same concentration as salty, or will it decrease? So I'm going to remove. Yep, and as you see, when I remove the solution, the concentration remains the same, right? So that's the same as I have my soup and I scoop out the soup, right? Each of the scooped out soup will taste as salty as the soup, the original soup itself. Okay, now what happens if I evaporate the soup, right? So would it become saltier? Will it become more concentrated if I evaporated the soup? So let's watch the concentration as I do the evaporation. So as you see, when I evaporating the water, the solute, which is the salt, remains there. So the concentration actually increases. So this concept here is very important. When I have water and when I add a solute, the concentration increases. When I have a solution and when I add just the solvent, the concentration decreases because it becomes less concentrated. If I have the solution and I just remove the solution, the concentration remains the same. And if I have the solution and I evaporate off the solvent, my concentration increases. Okay, so this is the conceptual understanding of what concentration is. And in the next video, we will explore the calculations for concentration. So all the best. See you.